Hi everyone, my name is Ruhi and welcome to session 2 of our Java for Robotics crash course video series. Today we'll be talking about a couple of the variable data types in more detail. So let's go through the Java data types once more. So this is just a general overview of what are data types. So what is a primitive data type first? You'll notice over here that data types are split up into primitive and non-primitive. So primitive data types are the types of a value. For example, a number, a character, etc. And then in Java, there's specific categories, and each one has their own function. So the four primitive data types are int, float, char, and boolean. And basically, these are all predefined in Java. So you don't have to do anything additional to them because they already exist and everything's perfect there. And so what is a non-primitive data type? So non-primitive data types are the ones that have specific functions associated with them. So non-primitive data types include a class, an object, an array, a string, and interface. So this just means that you can apply functions to make them do different things. So for now, we're going to focus on the three of the primitive data types plus strings, which are int, float, char, and string. So first, integers and floats. Again, integers, very similar to mathematics. An integer is defined as a whole number, which can be either positive, negative, or zero, as long as it has no decimal place. So Java integers are basically data types which can hold mathematical integers. And remember, as I just said, Java integers cannot have decimal places. And then on the other hand, floating point decimals are decimals. So if you want to store a variable with decimals in Java, you should be using a float data type. So basically a float is an integer with a decimal component. Keep in mind that you don't always have to add a decimal component to a float. If you want to assign it to just 3, that's also okay. Just know that you have the freedom to add the decimal points. So let's see a couple examples of integers. So for integers, 1, 2, -10, 500, these are all integers. And then for floats, 0.123, 3.14, and -93.04 are all floats. So notice how negative numbers do not affect it. As long as it has like the decimal point, then it's a float. And if there's no decimal point, then it's an integer. All right, some other number types which aren't as used in Java, but are still good to know are a byte, a short, int, of course, long, float, and double. All right. Keep in mind that we can do completely regular mathematical arithmetic operations with integers. So there's 5 arithmetic operations in coding in Java. It's the plus, minus, multiplication, division, and modulus. So first, going through the ones that we already know. So these are they work exactly how they do in math. But notice how if you try to print out 16 divided by 3, it'll print 5. We obviously know that 16 divided by 3 does not evenly divide into 5. It's more 5 and 1/3. So the reason why this happens is because Java sees 16 and 3 as both integers. And when you divide an integer by an integer, you have to result in an integer. So obviously 5.33333 is not an integer, which is why it automatically rounds down always to the nearest integer, which is 5 in this case. And then when you have any long equation, just keep in mind you're going to use PEMDAS just like in math. So it's going to be first parentheses, then exponents, then multiplication, division, and then last addition and subtraction. And you can also do arithmetic inside the Java code and just display the result by using the system.out.println feature. Yeah, so this is some examples of that. So to add, you can just say 2 plus 3, subtract 5 minus 4, multiply 3 times 8, and division is 16 divided by 5 would equal to 3, as we just discussed. Also, modulus is a new operator, of course. Not many people have heard of it because it's not something that we use in math. But the mod operator is basically represented by this percent symbol. And all it does is give the remainder. So obviously 16 divided by 5, the answer would be 5 with the remainder of 1. So the answer is 5 over here. If you were to do 17 mod 3, you would get 2 because 17 divided by 3 is 5 with the remainder of 2. And then if you give your Java code a equation like that, it would just use PEMDAS. So it would first do 4 plus 3 inside the parentheses and do 7 times 2, which is equal to 14. All right, now let's talk about the last primitive data type, which is Booleans. So Booleans store only true or false values. You cannot store any other value in a Boolean. So an example of a Boolean is bool is happy is equals true. So keep in mind, generally, when you name your Boolean, it's going to be asking some form of a question, like is happy, is sad. And then Booleans are used in conditional processing, which we'll talk about a little bit later or in another video. But for now, we can see how they're used for as comparison operators. Okay, next is characters. So what is a character? A character falls under the category of a primitive data type, and it's pretty simple. It's just a simple data type and can be either letter, number, or special character, as long as there's just one of them. So not a word, not like a series of numbers, just one number, one letter, one special character. So to declare a character, you're going to use a short form char, and then of course say the name of your character, and then equals, and then in single quotes to show that it's a character, not a string, you're going to put whatever your letter or number is. All right. Typecasting. Typecasting is very important for variables. So typecasting is basically when you have a variable which is assigned to one primitive data type, but you want to cast it or assign it to another primitive data type. So there's two types of casting in Java, widening casting and narrowing casting. So widening casting is basically converting a smaller type to a larger type. So you'll notice here a byte can store the least amount of numbers. I believe a byte can only store one number, while a double can store up to 15 or 16 decimal points. So if you were to cast a float to a double, it would basically expand the range that it can create. And then on the other hand, narrowing casting is when you convert a larger type to a smaller type. So again, a double can have up to 15 to 16 decimal points, while a float can have less. So when you convert the double to a float, it would round down to only have a certain number of decimal points. All right, here's some examples of typecasting. So widening casting. So to cast, keep in mind, you use parentheses, okay? So you're going to say, or sorry, not parentheses. You're just going to reassign the variable to another primitive data type. So let's say over here you create one variable as an integer. So you say int my int equals 9, but then you realize that you actually want it to be a double. Then you're going to just reassign it, and you're going to this time call the data type a double, and then say my double equals my int. So you're assigning the variable my int, you're storing whatever value was in my int now into my double just as a double. On the other hand, if you want to go from a double to an integer, this time you'd have to do manual casting. So if you want to do narrowing casting, keep in mind that you have to use these parentheses. So over here, I create my double, my double equals 7.78. You can ignore the D for now. And then when you want to put it into the integer, you're going to say int my int equals, and then Java will throw an error when you just say equals my double because you're trying to do narrowing casting, which is why you explicitly have to put the parentheses over here to show that you're casting my double to an integer. All right. We can also convert integers to strings, even though they're not both primitive data types, but we would do this a little bit differently by using functions. So a function of the string class that you can use is string.valueOf, which basically converts an integer to a string. So you would you would maybe assign it to a new variable string. So you'd say string s equals string.valueOf, and then inside the parentheses, you'd put the number. So that would now be converted into a string. And then if you want to convert something from an integer to a string, you would just use this function over here, integer.toString, and then in the parentheses, you would put the string. All right. Okay, let's do a quick challenge problem. So create a program which asks the user for the ages of 3 of their best friends, and then convert the strings into integers, and then print out the average age of the friends as a float. Pause the video and try this out really quickly. All right, so this is the answer. So this is all just asking for the user input and storing it into 3 different variables. And then you can just, oh yeah, and notice how when you are storing it into the variables, right over here, we are converting the string into an integer by using integer.parseInt, or you could use or you can use integer.to, or you can use string.valueOf. But yeah, here we're using integer.parseInt. And then once it's all been stored into an integer, we can just now cast it to a float by putting parentheses around that and then putting parentheses over there to cast this to a float and then divided by 3 to get the accurate average age. All right, last problem. Try to create a program which takes two numbers from a user input and calculates them in 5 different ways using the arithmetic operators that we just learned. And then output each answer and the arithmetic used. You guys can pause the video and try this out. All right, cool. That was the end of our session 2 of this video. I hope you guys learned something new. If you guys haven't already checked out the first video of the series, please go ahead and check that out. That has some important information about Java and the basics of variables. So it's definitely good. Yeah. All right. Thank you guys for listening.